Welcome back. As promised, we're going to be looking at how we can use the geometric sum. And I have a problem that is kind of classic for these, and that is that you put money into a bank, and every year you put in the same amount, and you have the same interest, and the interest grows along with everything else. It's the compound interest problem. So let's take a look at it. We have a little boy who turns 1 year old, and he gets 1,000 crowns on his birthday, and it gets put into an account, and it has 3.5% interest. And then every year on his birthday, he gets another 1,000 crowns, and the whole time the interest is building up and it's growing. And then he gets 1,000 crowns on his 20th birthday, and he puts it in. And the question is, how much money is in the account now? This is a classic for this kind of geometric sum. So let's take a look at the next picture here and see the description of what's going on. We have the timeline in the green there, and we have 1 year, 5 year, 10, 15, all the way up to 20. And you can see that I have, let me just get the pen here. You can see that I put in, here's the 1,000 crowns that he gets on his 20th birthday. So it doesn't have time to earn interest. He gets it, and then we just add up all the money and see how much do we have. The year before his 20th birthday, so when he turned 19, he gets 1,000 crowns, and that 1,000 crowns has 1 year to grow at 1.035%. Or, well, we're saying it's the 3.5%, but then we multiply it by 1.035 because that's the easier way to do it, so that you don't have to add up each individual step. We learned that little trick in Math A. All right, so I put down several of the years, but not all of them. That's what these, dots are, because it would get rather crowded, as you can see. But it shows you the idea. And you can see that the further back in time I go until he's 1 year old, see, the money we put in when he was 1 year old, it has 19 years to grow. The interest on that 1,000 crowns there, it has 19 years. And then the 1,000 crowns that he gets when he's 2 years old, well, that wasn't when he was 2. When he is 2, though, that would be down here, and it would come over there. Okay, it would have 18 years to grow. All right, I'm going to change this just a little bit so that it can be more familiar to the geometric sum that you used to and that you saw in the last film. So let me do that. All right, here we are. Now, what did I change? Well, here you can see that I put the interest to the power of 0, and here to the power of 1, instead of, like, let me just go back for 1 second. See the difference there? In the 2 up there on top, I didn't do the power thing, and now I do. And that's because I want you to see the pattern of how it's working, so that you can more easily identify, okay, what is the K, what is the A1, and so on. It doesn't really change anything, because what is this number to the power of 0? 1. And what is this number to the power of 1? Itself. So it doesn't mathematically change anything, but it makes it just a little bit easier in the beginning to see how we're going to do this. All right, so let's go to the next step. What do we need to do? Well, we knew from last time that we have a formula for the geometric sum. So what we need to do now is identify what is A1, what is K, what is N. All right, so how are we going to do that? Well, that's why I rearranged it a little bit so you can more easily see it, and why I used colors. So here goes. Now you can see here, I did the A1. That is the yellow stuff here, okay? That's those guys. K in the red, and it's both of those. That is the interest that we're going to get. And the N, now I need to clean up. The N in the green, that comes from the timeline, and that's the number of times that we're putting money into an account. Now, it's easy to get confused at least in the beginning, that sometimes people want to put the wrong number in for n. But just think of it this way. You put in 1,000 crowns when you're 1 year old, when you're 2, all the way down to when you're 20. How many times did you do that? And then it becomes more clear as to why n equals 20. Some people, when they see this, want to say, well, n is 19. And that would be wrong. It isn't. 20 times that we put money into the bank. All right. And being that he started off at year 1, when he's 1 year old, and goes until he turns 20, that means that the original rounds had 19 years grow at that rate. Okay. So that being said, now that we know what K and N and A1 are, we just put it into the formula and out comes the answer. And I rounded it off to the nearest crown. 28,280 crowns is what he'll have when you put that last 1,000 crowns that he gets on his 20th birthday into the bank. So, not bad, is it? It'd be nice to have an account that actually paid 3.5% interest. I think the latest one I looked at, I'm getting 0.1. So, well, perhaps someday. But, well, I hope this works for you. Try some of the problems that I gave you, and good luck. I'll see you next time.